For hundreds of years, fire has been used to improve our lifestyle, but it's always been an uneasy partnership. As one of the most powerful elements to be harnessed by industry, fire has been a key to the development of our civilization. However, its capability for destruction is just as powerful and should never be underestimated. Along with the benefits of fire has come the need to develop the equipment and the methods for fighting and controlling fires. Let's begin by looking at the way a fire starts. In simple terms, a fire results from a combination of three ingredients: fuel, oxygen, and a source of ignition. This is often represented or referred to as the fire triangle. Therefore, it follows that firefighting principles are based on the interruption or removal of one or more of the ingredients of the fire triangle. There are four common methods of fighting a fire. By stopping the fuel flow, we simply remove the fuel from the vicinity of the fire. Remove the fuel, and the fire goes out. A fire needs oxygen to burn. Removing or reducing the oxygen available to a fire can often be done very simply. The same result can be achieved by applying an extinguishing agent, such as foam or carbon dioxide. By cooling, we can reduce the temperature to a point which is below the level required for combustion. A range of dry chemicals have been developed which, when they're applied to a fire, prevent or interrupt the chemical chain reaction. Often, it is a combination of methods which extinguishes the fire. Portable extinguishers use a variety of extinguishing agents: water, foam, carbon dioxide, halon, dry chemicals, and dry powder. Because of its availability and low cost, water is the most commonly used extinguishing agent. Its effectiveness is due to its ability to absorb heat from both the burning fuel and the heated vapor. Firefighting foam forms a covering layer on the surface of a liquid, thus denying the fire oxygen. And because 90% of firefighting foam is water, foam also reduces temperature. Water and firefighting foam should never be used on electrical fires, as they will conduct electricity. Carbon dioxide displaces oxygen, which is one of the ingredients of fire. Halon is an alternative for the protection of delicate, sensitive electronic equipment, as well as tapes and films. A major problem with carbon dioxide and halon is that if they are used in a confined space, the toxic atmosphere created may make the area dangerous to human life. There are many chemicals which are used as fire extinguishing agents, with the additional benefit that they will not conduct electricity, unlike foam and water, but will break down the chemical reaction. All of the extinguishing agents that we have just looked at can be delivered to the fire by using a fire extinguisher. For easy identification, fire extinguishers are marked, either with these letter symbols or with a series of pictographs showing what type of fires the extinguishers should and should not be used on. In order to determine the right type of extinguishing agent to use on a fire, we must first learn the four classifications for types of fires. Class A fires are ordinary combustibles such as wood, paper, trash, and cloth. Class B fires are flammable liquids such as gasoline, alcohol products, solvents, and oils. Class C fires are electrical. Remember, however, an electrical fire can often be turned into a Type A fire, or ordinary combustible fire, if the source of electricity is disconnected. Never assume that an electrical fire has been de-energized unless you know for certain that the electrical source has been disconnected. Even then, some electrical devices can store electrical charges which may be dangerous. Always treat these fires as if the electrical power is on. Class D fires are metals which burn, such as magnesium or lithium. Some extinguishing agents will put out only one class of fire, and some are suitable for 2 or 3 classes of fire, but none is suitable for all 4. Before using any extinguisher, some simple checks should be carried out. With most extinguishers, you can check the gauge to see whether the extinguisher is fully charged. Carbon dioxide and cartridge-operated extinguishers, however, do not have gauges. Remove the safety pin and test operate to check the discharge range of the extinguisher before approaching the fire. If your workplace has cartridge-operated extinguishers like these, ask your supervisor for further details. It is best to have the wind behind your back, but it is of the utmost importance that you have a clear escape path at all times. Now, let's examine the techniques used with the different types of fire extinguishers. First, the water extinguisher for use on Class A fires. The water stream should be directed at the base of the flames, working from side to side. As the flames diminish, change the stream to a spray by placing your finger over the nozzle. A spray is more effective in reducing the temperature of embers. When you have controlled the fire, separate the pieces and dampen down the hot spots to ensure that the fire is completely out. A 2.5-gallon water extinguisher will operate for between 45 and 50 seconds. The same principles apply to a fire hose. However, it will supply an unlimited amount of water, and its operation requires 3 simple steps. First, run out the entire length of hose. Second, turn on the valve to charge the hose with water. Third, turn on the water at the nozzle. Both stream and spray options are available by rotating the nozzle. Next, the foam extinguisher for use on Class A and B fires. With the foam extinguisher, a completely different technique is used. The foam must form a blanket on the flammable liquid surface. Thus, the stream should be directed against the inside back wall of the container and the foam buildup allowed to spread over the surface. If this is not practical, the foam can be applied gently to the surface of the liquid and allowed to form a blanket. If the blanket is disturbed, momentarily direct the stream away and allow the blanket of foam to reform. In the event the flammable liquid is uncontained, the stream should be directed immediately in front of the fire and the foam allowed to drop onto the surface. Foam can also be used on spills of flammable liquid to prevent fires. The foam stops ignition by preventing the release of vapors. The foam extinguisher also has a number of air holes located on the nozzle to facilitate operation. These should not be obstructed during use, or the expansion and effectiveness of the firefighting foam will be diminished. Carbon dioxide extinguishers are rated for use on Class B and C fires. For flammable liquids, begin at the near edge of the fire and sweep gently from side to side to the back of the fire. For electrical fires, direct the discharge at the source of the flames. Whenever safe to do so, turn off the power to the equipment. Otherwise, the fire may reignite. For confined fires, an overhead method may be the most effective. Point the horn downward at an angle of about 45 degrees toward the center of the burning area. The horn of the carbon dioxide extinguisher can cause freezer burn if touched during or after use. Remember also not to handle the snow produced by the carbon dioxide extinguisher. The horn can also conduct electricity, so remember to keep it out of direct contact with any electrical equipment. Apply carbon dioxide even after the flames are extinguished in order to allow time for cooling and prevent reflash. Carbon dioxide puts out a fire by displacing oxygen, which is one of the ingredients of fire. Only use carbon dioxide extinguishers where adequate ventilation is available. Halon extinguishers are rated for use on Class B and C fires. Larger halon extinguishers, those of 9 pounds and above, are also rated for use on Class A fires.
Halon extinguishers have a more violent discharge than carbon dioxide extinguishers, so stand further from the fire when using a halon extinguisher.
For flammable liquids, begin at the near edge of the fire and sweep from side to side to the back of the fire. For electrical fires, direct the discharge at the source of the flames. After putting out the fire with a halon extinguisher, stand by. Don't use more agent than is necessary because halon reacts with fire to produce toxic byproducts. Halon must only be used in well-ventilated areas. A common type of extinguisher that carries a multi-purpose A, B, and C rating is the dry chemical extinguisher. Aim the extinguisher at the base of the fire and discharge the extinguishing agent, sweeping back and forth slowly at first, then increasing the speed of the sweep as you move in on the fire. When applying the agent to a Class B flammable liquid fire, try to avoid splashing the flaming liquid out of the initial fire area. Don't use more agent than required. The fire may flare up again and you'll want to be able to knock it down with the remaining agent. When using a dry chemical extinguisher on a Class A fire, you'll need to break up the fire after you've controlled it and coat the hot spots. Dry chemical doesn't cool. It coats and forms a residue which excludes oxygen. If used indoors, a dry chemical extinguisher will create quite a mess and is harmful to electronic equipment. It is not recommended for use on computers. Halon is an alternative agent. The Type D extinguisher is rated for use only on burning combustible metals or combustible metal alloys. Hold the nozzle over the fire while discharging the agent. Cover all the burning metal. After initially controlling the fire, decrease the flow rate and pour the dry powder over the metal. Check for hot spots, reapply the agent where necessary.
Class D extinguishers are intended for use on specific metals. Read the manufacturer's instructions carefully. The following general guidelines apply to firefighting and the use of portable fire extinguishers.
Learn the classification system for types of fires and the appropriate extinguishers. Familiarize yourself with the location, type, and method of operation of the fire extinguishers in your workplace. When attacking a fire, always turn in an alarm first. If possible, don't fight the fire alone. If you have one or more extra people and extinguishers, fight the fire together. Approach with the wind behind your back whenever possible, but make sure you can see each other. And remember, it is vital to have a clear escape path at all times. When using a dry chemical extinguisher on flammable liquid, be aware of the possibility of reflash if the fire is not completely extinguished. Due to this possibility of reflash, you should never turn your back on a fire just because it appears to be extinguished. Extinguishing agents like carbon dioxide, halon, and dry chemicals are only effective when reaching the fire, and they are quickly dispersed by wind. After testing the discharge range of the extinguisher, be sure to get only as close as necessary to the fire to extinguish it. When in doubt, stay back. It's always easier to move in on a fire than to get back if you're too close. Good safety practice should reduce the risk of fire and enable clear access to fire extinguishers at all times.
An extinguisher is made to be used once and only once before being refilled and recharged by a professional. Never return a used extinguisher to its original location where it can be mistaken for a fully charged extinguisher. Always make sure it's refilled and replaced as soon as possible.
Fires usually start small, but can quickly grow to dangerous proportions where life and property are endangered. If a fire is discovered early enough, decisive and informed action using a fire extinguisher can prevent costly damage to property and, more importantly, save lives.
Stop it burning by knowing your equipment, having it properly maintained, and by approaching a fire in a sensible manner.